let's first look at the warm-up and kind of what it's talking about, because a big part of this is you will actually have to set up the system of equations. So you'll have to write the equation. Now, looking through it, says the cable TV provider offers different packages, whatever. So option 1, 2 sports channels, 1 movie channel, 1 concert channel for $20 a month, and so on. Now, whenever you're doing these, you could very easily use S, M, and C for sports, movie, and concert. All right, normally I will use X, Y, and Z, but it's best to identify what those are. A lot of times you're going to be asked to do it, and a lot of teachers are kind of strict on that. I guess I kind of am too, but I use a little bit of a shortcut on how I identify the variables. So as I'm reading through the sentence, I'm going to put X over what I'm using X for. I'm going to put Y over what I'm using Y for, and in this case Z and what I'm going to use Z for. And if you do that, in my mind, if we're grading and you get, or you receive or you don't receive a point for identifying your variables, if you do that, you identified your variables. Okay? So then I go to the next one. I've got 3 sports channels, 2 movie channels for $30, 1 movie channel, 2 concert channels for $18. This is whenever you have to be really careful, because those last 2, they don't have all 3 options included in them. It's just 2. So don't just automatically do X and Y for the first ones you come across. The reason why I like this is the way that's written. I think you're a lot closer to the equation than if we went off to the side and says X sports, Y whatever, Z whatever. Because now I can go back and I can read through the equations, and I have 2X, 1Y, 1Z equals $20. Okay, now you don't have to go in and circle and underline like I did there, but hopefully you get what I'm saying here. You can go up to the equation. You already have X by it, so 3X plus 2Y equals 30. Whenever you're writing your equations, I would highly recommend that you keep them in order by columns. So there's no Z here, so I'm going to leave a blank space in that area. That equals $30. And then I've got 1Y. Since I don't have an X, I'm not going to have one out there. 2Z equals $18. All right. Now we're not going to solve this one yet, but this is kind of an open-ended question here. Somebody throw out an idea as to how you would attempt to solve that system of equations.
Common denominator?
Nope.
See, my hillbilly mind wants to do 2x, so it's going to go to 10 because I'm multiplying by 5.
Okay, now you're getting painful here.
10.
Okay. Okay, so let's think about all the stuff we did last class. What were the 2 methods? Substitution, elimination. So let's kind of talk about how we would attack this if we went substitution. So whenever I do substitution, we talked about certain things I would look for, because you'd have to solve for a variable, but we kind of talked about what to look for to make the problem easiest for us. So looking at that problem, which variable in any of the equations would I solve for? Which one would be the easiest to solve for? Do what?
1.
Okay. So I heard 2 people say Y's. I've got 3 Y's. Which one? This one, or this one? The top one? Noel? Okay. Now I would go with the third one. So Noel, why not the first one instead of the third one?
Because the third one has less variables.
Okay, so the third one only has two variables. If I solve for this y, yeah, I get it. It has a coefficient of 1, but I'm going to have to move two terms over to the right. The second one is pretty obvious, hopefully. Y has a variable. All right, eventually I'm going to have to divide everything by 2, which means I'm going to have 3 over 2. And now I'm talking about fractions and decimals, and if I can avoid that at all costs, I'm going to. So, substitution. Let's put I would solve for y in the third equation. After that, we're going to use substitution. And you'll see how much of a pain that is in a 3x3 system. Okay, but after we do that substitution, we are now back to a 2x2 system, which is what we did last class. Okay, so we're adding these two steps, and they'll be a little lengthy, but then we're going to get back to a 2x2 system and solve it like we did last class. Okay. If I was to do elimination, okay, somebody, what variable would we try to eliminate here? What would be the easy?
Z.
Okay. I would go Z, and elimination's kind of weird. The strategy, because there's 3 equations. And so we won't get too detailed in these notes, but we will eliminate the same variable in all 3 equations. So once we go through that example here in a minute, you'll see that once we eliminate one of those variables, again, we're now at a 2x2 system, and it's what we talked about last time, and it's what you talked about in Algebra 1. And, hopefully you're comfortable doing that. Okay. So the first one we're going to tackle is substitution. As we're going through this, do your best to stick with me. This is probably going to be one of the more complicated problems we will see. Alright, so stay strong here. So looking at that problem, Will Maroney, what variable do you think would be easiest to solve for?
Y.
In which equation?
The first one.
Okay. So I'm going to solve for that y right there. So just focusing on that equation, I'm going to change this to y equals. Now, how am I going to move that negative 2x over to the right? I'm going to add 2x. I don't need to put plus. It's going to be positive 2x. How would I move the positive 3z over to that side? I'm going to subtract 3z, and I still have positive 20 over there. Looking at this, we are going to take this whole thing right here, 2x minus 3z plus 20, and we are going to substitute it into the other 2 equations for y. Into equation 2 and into equation 3. So, first, let's do equation 2 right here. Okay, so looking at this. Okay, so looking at equation 2. This one right here. Alright, I'm going to go through it. So I've got negative 3x plus 2. Oh, sorry, not y.
I'm so confused. We have another equation? Is this for the next
No, I'm writing this right here. Instead of y, I'm going to plug in 2x minus 3z plus 20.
So we already rewrote the first one on the top.
We solved for y in that, yes.
Oh, we're plugging in y.
And then I still have plus z equals 21.
Wait, why do you have to do it to the other equation?
Do what?
Why do you have to do it to the third equation?
To the third equation? Well, because after we do this, we're going to get one equation with two variables. And then we'll go to the third one, we'll get another equation with two variables. And then that's going to be our 2x2 system. Okay, any questions on how I got to that point right there? Okay, so now we're going to take that and we're just going to simplify it down. So you'll distribute your 2. And again, guys, I feel like this is a really long process. I don't think it's really hard, it's just long. Okay. Well,
It'll be plus 40.
is it 40? It is 40.
It is 40.
I'm losing my mind here.
6C. There you go.
So all I did was I distributed the 2. And now I'm just going to go through and I'm going to combine my like terms. So I've got negative 3x plus 4x, which is going to be what? 1x. After that, I've got negative 6z plus z, which is what? Negative 5z. And let me backtrack. Sorry, I meant to say this earlier. Whenever you're simplifying, we're trying to get it into standard form. Sorry, equals c, not plus c. And a good rule of thumb on standard form, everything that has a variable needs to be on the left. If it does not have a variable, move it over to the right. So if I have a positive 40, how would I move plus 40? Subtract it. And 21 minus 40 is negative 19. So that is going to be one of my equations in this 2x2 system. Because now I'm going to take equation 3, and again I'm going to plug this in for y. So I've got 3x minus minus 2, and then now I'm going to put 2x minus 3z plus 20 plus 3z equals negative 9
Oh, so we re-plug in that equation again?
into the third equation.
Oh, we don't plug in that x one.
3z, yes.
So it's the same process again.
It's the exact same process with the third equation. So on this one, go ahead. You with me here, Jake? Yeah, there you go. Wakey, wakey. Okay? Okay.
Everything you've said.
So I'm going to distribute this negative 2. Make sure you're taking the negative with it so that you get 3x minus 4x plus 6z minus 40, and then plus z3 equals negative 9. And then I'll go through and I'll combine my like terms. So 3x minus 4x is going to give me what? Negative x. 6z plus 3z is 9z And then if I add 40 to the other side, that's going to give me
39. 21.
31.
That's not. 31.
So that is the process of breaking it down from a 3x1 to a 2x2.
I subtract these two.
Now, in this situation, the obvious way to go about this one would be elimination. I understand that. But we're going to keep doing substitution through this whole problem. We're going to do elimination here in just a second. So, looking at these 4 terms right here with the variables, which one of those is going to be the easiest to solve for? The x in the first or the second equation? Why not the second one? Because it has a negative. So I'm going to take that first equation. I'm going to add 5z so that I get 5z minus 19. And then I'm going to plug that in for x into that equation right there. So I'm now going to take, please pay attention, I'm going to take the 5z minus 19, and look up here, here's a common mistake, do not forget that negative, because that's going to change the 5z and the 19 in there. So I plug that in, plus 9z equals 31. Now I've got one equation with one variable, so I can solve for z now. Distribute my negative. After that, negative 5z plus 9z is 4z. And then if I subtract 19 to the other side, that ends up giving me 12, I believe. And so z equals what?
3.
Yes, ma'am. Yes. All right, now we still have to find x and y. Now, here's the good thing. Listen, we're on the home stretch here. Okay, for me to find x, listen, and this is you being able to recycle the work that you've already done. Do I have an equation that is already set up as x equals? Yes, because whenever I say we got to solve for x and y, you look, there's x's and y's all over the freaking screen up there. Okay, but if you go back into your work, what you're looking for is this. We already have an equation that's set up as x equals. So I'm going to do x equals 5. I'll plug 3 in for z minus 19. So that's going to give me 15 minus 19, which is negative 4. Up here in orange, so I can take that, kind of run out of space up here. I've got y equals 2 times x, which we just found was negative 4. Minus 3 times z, which we found was 3, plus 20, which that's going to give me negative 8 minus 9, which is negative 17, plus 20, which is 3. So y is 3. A lot of times you will see your answer given like this on these kind of problems. Okay, and it looks like a coordinate with an extra value at the end, and that's just x, y, and z, negative 4, 3, 3. Okay. So, like I said, I do think elimination, the process we're about to do, is a little bit easier. So once you got that written down, don't go to the next problem. The next problem is another example for substitution. Go to the one that is talking about elimination. Did everybody get that written down? Let me pop that back up there. So looking at number 5, the first example of elimination, let's go through this. So it's going to be a little bit different, L, on how we set this up. Okay, the very first step, and this is kind of new to you, so don't freak out here. I'm going to take the first and the second equation, and I'm going to set them up right on top of each other. I'm just rewriting the first equation and the second equation on top of each other. And then off to the right of that, I'm going to rewrite the second equation, and then below that I'm going to write the third equation. Oh, messed that up. That's the first equation again. Sorry, second and third equation. To give myself space to work. You'll see why I need the space there. So there's the second equation again, and then underneath that I'm going to write the third equation. So as you're writing that down, just kind of listen. Now I'm going to have to, I've kind of got it into two different sections here. I need to cancel the same variable, eliminate the same variable here that I'm going to eliminate here. Now, this particular problem, there's a really easy shortcut way to do this to get to the final answer quick. We're not going to do that because that's not in every problem you're going to see. Okay? So, looking at this, which variable, x, y, or z, looks like it would be the easiest to eliminate in both systems? Yes? Okay, z is positive in both equations, but no. Okay. So, why?
Because in elimination you can multiply from the first and second, the y, can be easily eliminated, and then in the second and third equation, it's already eliminated.
Okay, so let me kind of reword what Noelle's saying. She's absolutely correct. Y is obviously easy here because it's already going to eliminate 2y and negative 2y. Over here, all I'm going to have to do is change this to negative 2y so that it will eliminate here. The reason why it's easier than x, because you got the same situation with x here, but on the x here, you're going to have to end up changing one of these to positive 6x and the other one to negative 6x so that both x's will cancel. The path for the least work is to eliminate the y. So let's do that here first. So if this is 2y, I need the one on top to be negative 2y. So I'm going to multiply that whole equation by negative 2. So that's going to give me, and I'm just gonna rewrite after I distribute. I'm gonna rewrite that equation underneath the second one, this one right here. Okay, so negative 2 times negative 2 is going to give me 4x. Negative 2 times y is going to give me negative 2y. So that right there, I've accomplished what I wanted to, because I got 2y and negative 2y. Then negative 2 times 3z is negative 6z. Negative 2 times 20 is negative 40. So once I have that, now I'm just going to do what I did with the elimination stuff last class. With my x's, I've got negative 3x plus 4x, which is 1x. Like I had already said, my y's, I got them doing what I want them to do. They're going to eliminate. What is z minus 6z? Negative 5z. And 21 minus 40? Negative 19. Alright. Going to the second one over here. Like Noel said, the y's already canceled. I don't have to do any work on this one other than going down. Okay? Now, on this one, we're also lucky. And this kind of has to do a lot with the shortcut that I was talking about. And we're not taking full advantage of it here because I want to go through the whole process. But both of them cancel. And I end up with 4z equals, what does that give me? 12? So, once you get that written down, I want everyone to put their pencil down for me. Because I definitely do not want you writing this next. I definitely don't want you writing this part, but please pay attention. Okay. Let's say I did all that work, and let's say I did get something with x. Alright? That's whenever you would take these two equations, you would write them on top of each other, and you would do elimination again exactly like we did last class. Okay? That is actually more likely of an outcome than what we're going to have here. Okay? You would still, you got your 2 by 2 system, that should be plus 4z. 2 by 2 system, you bring it down, and then you work your way down from there. Alright, but on the problem we're given here, the x's and the y's cancel. So here, I've hit the jackpot, and I got one equation with one variable. So I can solve for z right now, which would be what? 3. I then need to take my 3. I need to look back through my work for any equation that has z and only one other variable. So this right here. So I'll go x minus 5. Instead of z, I'm going to plug in 3 equals negative 19. Then I'll solve for x there. So I end up with x minus 15 equals negative 19. X equals negative 4. Negative 19 plus 15. Okay. Probably the only bad part about elimination versus substitution whenever you're doing this is if you remember in substitution, I kind of referred back to your previous work. You already had an equation that was set up as y equals. You already had an equation that was set up as z equals. So you didn't have to do a lot of extra work. On this one, using elimination, you won't have that. So I would just pick the equation that looks like it's going to be the easiest. So I'm going to have 2. We found that x was negative 4. It is negative 2. Negative 2. X is negative 4. We have not found y yet. That's what we're looking for. Plus 3. We said that z was also 3. Equals 20. Then I would solve it from there. So that would give me 8 plus y plus 9. 8 plus 9 is 17. 20 minus 17 is 3. Okay? You may not have noticed, I don't know, maybe you did. This is the exact same problem we just solved using substitution. And you can see how much less work there is up there. A lot in due because of that shortcut, because the 3x is canceled. Okay. So, the last problem we're going to do, I want you to go to 8. Okay, here's that problem we did in the warm-up. Okay, but I want you to go to this next problem, because there's some sentences in here that always give students trouble when writing an equation. Okay, so let's look at this. It says a college student is shopping for clothes and needs to buy an equal number of shirts and ties. He also needs to buy 4 times as many shirts as pants. Shirts cost $35, ties cost $25, pair of pants cost $40. So hopefully it's obvious already what my variables are going to represent. And that is shirts. Since shirts is the first word I see, I'm going to put X on that. Ties right there. And I'm going to go through this whole problem. And everywhere where I see shirts, I'm going to put a little X. Ties, a little Z, or ties or Y. And pants or Z. And I think as you read through the sentence, if you have those up there, that might help you a little bit in having to write the equation. So let's look at these equations. First sentence. He needs to buy an equal number of shirts and ties. So what equation is that going to be? If you're thinking of an equation that you feel looks kind of weird, you're probably right. I need an equal number of shirts as ties. Do what? X equals Y. Okay. Those are probably some of the hardest equations to come by whenever you're comparing two different variables. Alright? So that, or, he needs 8 more pants than he does shirts, or 2 less this of that, or whatever it may say. Those are those sentences that give most people trouble. The next one is the same idea. You're comparing 2 different ones. It says he also needs to buy 4 times as many shirts as pants. So that equation, and look up here real quick, is that going to be this? Let's see, that's X and Z. Is that going to be that? Or is that going to be that? He needs to buy 4 times as many shirts as pants. And this is why I'm pointing this out, because it's the first one. Okay? A good way to look at this, if he's buying 4 times as many shirts as pants, what is he buying more of, shirts or pants? Shirts. So shirts needs to be by itself. The larger amount needs to be by itself. Because, look, and the surest way to make sure you got it right, come up with if you know he needs more shirts than pants, that's what that sentence is saying, you just can't put it into an equation. Make sure this makes sense. If he buys 2 pairs of pants, how many shirts does he then buy? 8. So he's got more shirts than pants. Okay? If it was the other way around, he would have had 2 shirts and 8 pants. So put an easy example in there, make sure that it makes sense according to the story, and then go from there. Okay? The last sentence, this is probably the easiest equation on this problem. This is that value equation. Last time I talked about, a lot of times you'll have the value equation or the number of equation. This is just that value equation. Alright? You got a shirt that's $35. You've got a tie that's $25. And you've got pants that are $40. And it tells us that he spent $560. Now, looking at this, there's an easy way to go about solving this. It's 3 by 3, yes. And that's a lot more work than 2 by 2. I can easily change this into a 2 by 2 by taking advantage of this. Okay? Because in this problem, is X and Y, are those going to be the same numbers? Yes. So what I would do is I would take this Y out, and I would put X in right there, so that I have 35X plus 25X plus 40Z equals 560. Combine my like terms. So I've got 60X plus 40Z equals 560. And then now, here's my 2 equations I'm looking at now. Can I easily substitute something in for X right here? What? 4Z. Okay? I know what X equals. It was one of my equations. So I'm going to put 60 times 4Z plus 40Z equals 560, and then solve from there. So I've got 240Z plus, not equal to, that's going to give me 280. And so how many pairs of pants is he going to buy? 2. This problem also has a lot of, to get the other 2 variables, a lot of easy ways to do it. So if he has 2 pairs of pants, how many shirts is he going to have? 8, because of this equation right here. How many ties is he going to have?
8.
So this one was not ties. This one was pants, shirts, ties. Alright, so you can tell sometimes 3 by 3 systems, they're not that hard if you know what to look for. If you have a problem like the very first problem we did, yeah, sometimes they're awful. That's just the way it is.